Okay, so here is quiz number 4, and question number 1. So x cubed, in fact, let me just put it on a fresh screen, x cubed minus x squared. So question number 1, x cubed minus x squared minus 42x greater than 0. So how do we solve x squared with greater than, less than kind of thing? Step 1, get a 0 and factor. So let's do that. And we've got a 0 already, but this is a greater than sign here, let's factor. So that would be x. Take out an x as the GCF, and then factor what remains. X is here. You're looking for two numbers that multiply to be 42 and add to be -1. When you factor, remember the diamond method? I don't know if you've seen that, where you want two numbers that multiply to be -42, add to be -1 right here. So that's 6 times 7 to be 42. The sign down here goes on the bigger, so it's plus 6 minus 7 adds to be -1, multiplies to be -42. So plus 6 minus 7. There we go. So it's factored. So it's step 1, get a 0 and factor. Step 2, find what x's make it equal 0. So what make this equal 0? So if we change to equals for a minute, because really basically at this point we want to graph this. We want to graph this, call this y equals, and graph it. That's the game plan, graph that thing. The way we graph it is we say, well, first off, what makes it equal 0? So 0 would make, x is 0 would make that part 0. -6 would make that 0. And +7 would make that piece 0. Okay, so now find what x's make 0, and now step 3, put on a graph. I'm going to do a graph, and at x is -6, at x is 0, and at x is +7. We have x-intercepts, right? Because those are values that make, if you plug any of those in, it makes y equal 0. So the function is at a height of 0. And so now we just need to find out where the function's above and below 0. So how do we figure that out? Well, we already know the end behavior. What I mean is we learned how to, the end, like what the graph is going to do in the end, whether it's going to go up or go down after the last x-intercept, is all about the most powerful term, right up here. If the most powerful term is positive, right, what that means is if you plugged in stuff way over the right, like 1,000,000 or 1,000 or whatever, that the most powerful term will overpower the smaller terms. And so if it's positive, which it is, the function's going up in the end, not down. If the most powerful term is negative, the function's going down. So this function's going up in the end. All right, and then we just come back to each of these x-intercept points, and we find out if it's going to pass through or bounce at each of those x-intercepts. The truth is, all these are first power, first power, first power. Remember, when it's odd power, that means it's going to pass through. It's going to pass through that one. It's going to pass through this one. So that's what the function generally looks like. So we got a general graph. That's step 3. So now we just can answer the question. They asked, where is this function greater than 0? Greater than 0. What's that mean? Positive. Greater than 0 is positive. Where's the function positive? Right here. It's greater than 0, and right here. Forever to the right. It's greater than 0. It's positive. So that means in this section of the number line and in this section. So that means the answer to this overall question then is from -6 to 0 united with 7 to infinity. In those two sections, all parentheses because we don't have a bar here, so no bracket, no equals. In those sections, the graph is above 0, greater than 0. The function is greater than 0. Okay, so now on number 2, we've got another greater than, less than kind of problem, but this time we have a fraction. So how do we handle greater than, less or equal to, greater than equal to, whatever, fraction? It's almost the same thing. Step 1, it's still about get a 0, make one fraction. So that's step 1. So I got to bring this 2 over, get 3x minus 5 over x plus 3 minus 2 less than or equal to 0. So I get a 0, and I got to make that one fraction. How do I make that one fraction? Put this over 1, multiply top and bottom by x plus 3. That way they'll have the same denominator. So now what do we have? 3x minus 5 minus 2 times x plus 3 all over x plus 3. So we combine them into one fraction by getting a common denominator. Now distribute that minus 2. So we get 3x minus 5 minus 2x minus 6 over x plus 3. Combine like terms. 3x minus 2x is x. Minus 5 minus 6 is minus 11 over x plus 3 less than or equal to 0. That's all step 1. Get a 0 and make it one fraction. We did. Now on to step 2. Write it in up here. X minus 11, x plus 3 less or equal to 0. So now we're on to step 2. Step 2 is numerator equal to 0, and that'll be x intercepts. Denom equal to 0, that'll be, vertical asymptotes. So we take the numerator, let me say, all right, x minus 11, where does that equal 0? That means x is 11, and then the denominator, x plus 3 is 0. Okay, and then step 3, we go to the graph. Go to the graph. So I'm going to go to the graph now, and I'm going to put over here at 11 and at minus 3. Those are the two. Oh, and actually minus 3 came out of the denominator, so it's a vertical asymptote, not a dot. So I'll put a vertical at minus 3, and it's an x-intercept where the numerator was 0 at 11. Okay, so now we have 3 sections. Do you see that? We have the left, we have the middle, and we have the right. Negative 3 and positive 11 are the separators. We have left, middle, and right. 3 sections. We have to find out what the graph looks like in those 3 sections. Is it above or is it below? In the middle, is it above or is it below? Over here on the left, is it above or is it below? That's what we got to figure out. So how do we figure that out? Well, we could, on the last problem, we did like end behavior. We could do that here. But really, when you have fractions, and therefore you have vertical asymptotes, it's best to just plug in a number in each section, because at the vertical asymptote here, it's not going to touch it. You never touch a vertical asymptote. See the last problem? When we got the graph here, then we found out whether it passed through or bounced at each of those places. So we just found out what it did in the end, and then we just traced it back. It passed through, passed through, passed through, and never bounced. So that was easy to do. Well, that's because it hits all those points. At a vertical asymptote here, it's not going to touch it. So it's not going to pass through or bounce. So my point is, in all that, is you're not going to be able to trace it back very easily. So when you have fractions, it's best to plug in. That's the moral of the story. I don't know if you followed that, but when you have fractions, plug a number in each section to find out positive or negative. That's what you want to do for the graph. in each section, I'm going to plug a number in to find out if the graph's positive or negative because I have a fraction here. Okay, so here we go. So something over here on the right side, so something like 12. You can plug in 12. Plug to this function right here. You always plug it into the one with 0. So what's that going to be? That's going to be 12 minus 11 over 12 plus 3. Y equals, what is that? That's positive over positive. That's positive. So that means at 12, the function's positive. It's up here. So the function is positive over here. It's positive. It's above 0. All right. Now, how about in the middle section? In the middle section, I'll plug in something like 0. Or you could plug in positive 1 or 2 or 3 or all the way up to 10 or negative 1 or negative 2. Anything in the middle between the negative 3 and the 11. Plug into here again. Y equals, plug in what? 0? 0 minus 11 over 0 plus 3, which is negative over positive, which is y is negative. So that means the function's down here. It must go down there, because at vertical asymptotes, it either goes up to infinity or down to infinity. I don't know if it exactly jogs like that. I don't know exactly what it does. All I know is it's below the axis all the way in that section. Right? Because it doesn't ever, there's no other x-intercepts, no other places it touches the x-axis, and it's below, so it's below everywhere. So now, finally, let's check a point over here in the left section, like negative 4. Plug in negative 4. So here, I plugged in, let me make sure you understood what I did. I plugged in x is 0 here. I plugged in x is 12 here. Got positive on the right section. Got negative in the middle section. And now, in the left section, I'm going to plug in x is negative 4 to this. So negative 4 minus 11. This is y equals negative 4 plus 3, so that's y equals negative over negative. That's positive, huh? So that's positive. What does that mean? That means the graph, kind of running out of room here, is up here positive in that section. So it's positive in the left section, it's negative in the middle section, and positive in the right section. What do we want? We want to know where is it less than or equal to 0. That's negative, isn't it? Where is it less? I'm kind of getting scribbly here. Where is it less than or equal to 0? Where is it negative? So that would be the middle, right in here. It's less than or equal to 0 between negative 3 and positive 11. And the 11 gets a bracket because we do have the bar, the equals. You want less than or equal to 0. So you do want right where it equals 0, which is right at 11. You want a bracket there. But the negative 3 is a vertical asymptotic line. You never touch those, so that's a parenthesis. You don't touch the negative 11. The negative 3. There we go. Okay, negative 3. Problem 3. They're asking f of g of 1. F of g of, what does that mean? That means f of g of 1. Like that. So you start on the inside, got to find g of 1. What do they mean g of 1? Well, you go up here for the input. That's the x. Right? Let me just get that word out. That's the x. And you want g of 1. So you want g. So you go crossed on g, down on 1, boom. So that inside becomes, well, here, let me just keep it at the top, the inside becomes negative 1. Like that, g of 1. Right? You put 1 into g, into g, and you get out negative 1. And now what is f of negative 1? Well, now you put negative 1 into f, and you get out negative 5. So that's the answer. Does that make sense, what we did there? Let's try another one. So again, I'll try with a different color this time. So let me erase these. For part B. So I'm going to go g of f of 1. So start on the inside, f of 1. What does that mean? Put 1 into f. Where do they intersect? -1. Again, that inside's -1. And then -1 now goes into G. So -1 into G, boom, boom, out comes +1. All right, let's do the third one. Part C. It's f of 3. So put 3 into f, zoom, and zoom all the way to here. 3, out comes a 3. So the inside becomes a 3, right? You put in 3, you get out 3. And now what is f of 3? Well, again, f of 3 is 3. It's just 3 both times there. So that answer comes out to be 3. All right, number 4, part A, wants f of g of 4. So how does that work? That means the 4 goes into G. So what happens when you put 4 into G? Let's try it. Oops. Two times 4 squared plus 4. What's that? 2 times 16 plus 4, 32, 36. So you get out 36. So that now, that's G of 4. Now, right, because it's f of G of 4. The inside G of 4 now becomes 36. Now put 36 into the f function. So this is the f function. 9 times 36. What's that? 270 and 54? I'm not sure. 270, you can just do that on a calculator. 4, 12, 3, 24, I believe. Yeah, 324. There we go. Let's try part B. G of f of 2. G of f of 2. Part B, G of f of 2. So that means G of f of 2, like that, right? And what is f of 2? Well, putting 2 into the f function, you get 9 times 2. That's G of 18. Oops. What is G of 18? Then put 18 in here into the G function. Right? G of 18 equals 2 times 18 squared plus 4 is 652. All right, part C is f of 1. F of 1. Start on the inside, do f of 1. Once that, you put a 1 in here. 9 times 1, that's f of 9. Now what's f of 9? Now you put a 9 in here. 9 times 9. 81. Finally, part D, G of 0. So G of 0. So again, that means a G on the outside and a G of 0 on the inside. So the G of 0 on the inside means plug 0 into the G function. If you work that inside, if you find the number on the inside, what is that? That's 2 times 0, 0 plus 4 is 4. G of 4. Now so we did the inner G on 0 right here, got 4. Now do the outer G, plugging 4 in again to the G function right there. You get 2 times 4 squared plus 4. What is that? 2 times 2, 32, 36. There we go. Okay, so number 5, part A, says find the inverse. How do we do it? How do we find an inverse function? So to find an inverse function, number 1, we switch, invert x and y. So do that. So this becomes x, this becomes y. That's step 1. Step 2, solve for y, get y alone. So to get y alone, subtract 2 from both sides. Divide through by 2. So what is that? X over 2 minus 1. So that's the inverse function. So the inverse function is, let's just write it this way, a half x minus 1, same thing, x over 2 minus 1, half x minus 1. That's the inverse function. This is the original function. And now what they want you to do is find the domain and the range of both. So let's do that down here. Let's say, okay. So here we have the original function. Oops, getting kind of scribbly there. 2x plus 2. And the inverse function, half x plus 1. So, okay. There's the original, there's the inverse. They want the domain. Let's find the domain of this guy. So what's the domain? Well, it's going to be all reals because there's no denominators, there's no square roots. Then over here they want the domain of this one, the inverse function. Same thing, all reals because there's no square roots, no denominators. And then they're going to ask for the range for both of these. And remember, for an inverse function, you're inverting everything, which includes domain and range. So domain of the original function inverts and becomes range of the inverse, which is all reals, and vice versa. So basically everything is all reals on this one. Next one will have a little more interesting result. So there we go on that, and then they just want you to graph both the function and its inverse on the same axis. So I think we can do that. So f of x is 2x plus 2. Let's put this on the axis. What does that look like, 2x plus 2? Remember, you start at 2, the y-intercept, up 2, and then this is 2 over 1, rise over run, so you go up 2 over 1, so boom. Right there, that's the slope, rise over run, so connect the dots. There's that line. And now for the other one, the inverse function, what was it, a half x plus 1? That one starts up at 1, and then the rise over the run for him goes up 1 over 2. So right there. Like that. All right, up 1 over 2. Yeah. So there we go, the function and his inverse. Okay, so we're supposed to, number 6 here, find the inverse. So the same 2 steps. Step 1, switch x and y. Step 2, solve for y. So this is y out here. So the y's will become x's and the x's will become y's. Like that. So we switch x and y. That's step 1. Step 2, solve for y. So put this over 1, diagonal, diagonal, cross multiply. So 1 times 8 is x times 6 plus y, distribute. 6x plus xy is 1 times 8 is 8. We're trying to solve for y. So subtract 6x from both sides. 8 minus 6x is xy divided by x. Boom. There's the inverse function. So the inverse function is 8 minus 6x. Well, I'm getting kind of sloppy there. Eight minus 6x over x. So that's the inverse function. So now we have the original function, which was 8 over 6 plus x. And over here we have the inverse function, which is 8 minus 6x all over x. Okay, so now we're supposed to do the domain and the range thing. So they want the domain of the original function. So what does that mean? Denominator, right, cannot be 0. Denominators can never be 0, so that means x cannot be negative 6. That automatically becomes the range of the inverse, because domains and ranges switch for functions and their inverses. So the range will be y, because ranges are always y, not x. Domains are x's, ranges are y's. Y cannot be negative 6. And now, come up here and let's do the domain of the inverse function. Again, denominators cannot equal 0, so that would be that denominator. X cannot be 0. That comes over and becomes the range, which means it's y not equal to 0. Like that. Okay. Okay, number 7. Again, they want us to find the inverse function. So how do we find it? Step 1, we switch x and y. So this is y out here. The function is always y. So that becomes x. And those two x's become y's. X's become y's and y's become x's. Step 1, switch x and y. Step 2 is solve for y. So put this over 1, diagonal, diagonal. X, we cross multiply. X times 3y minus 7 is 1 times 2y plus 9. Distribute. 3xy minus 7x. Distribute. 2y plus 9. Like that. And get a little messy here. And now we're trying to, this is where it gets a little tricky. We're trying to solve for y, right? What do you do when y is in two places? That's what we have going on here. Y is here and y is here. Two places. First, get the y's on the same side. Next, factor out y and divide. So get this term over here and get this term over here. So when things switch sides, they change signs. Whatever sign was in front of them switches. So this will become, whoops, I bumped it here. Try that again. This will become 3xy minus 2y, right? That plus 2y jumps over to the other side and becomes minus 2y. And then this minus 7x jumps to the other side and becomes plus 7x. So now I got the y's on the same side. Now factor out the y. Whoops. I factored out the y and divide. Divide by 3x minus 2. Boom. There is the inverse function. Make sure you know that for exam number 2. For sure on exam number 2 is this whole process where you've got y in two places. You got to get the y's on the same side, factor out y and divide. That'll for sure be on exam number 2. Now they want me to do the domain and the range thing. Last thing on this quiz. So let's go. The original function is here, is up here. 2x plus 9, so the original function, 2x plus 9 over 3x minus 7. Then over here, the inverse function, which is 7x plus 9 over 3x minus 2. And they want the domain and the range stuff. So I go, okay, domain. Here, denominator cannot be 0. 3x minus 7 cannot be 0, so 3x cannot be 7. Divided by 3x cannot be 7/3. Over here, that becomes the range. For the inverse, y cannot equal 7/3. And then domain over here on the inverse. Again, denominators cannot be 0, so 3x minus 2 cannot be 0. 3x cannot be 2 divided by 3. X cannot be 2/3. Bring that over. That's the range over here. Y cannot equal 2/3. And there's the quiz.